if I reset it, here's the e-ink display cycling. So as you can see, it's flashing, it's doing its stuff, and once it finishes, it takes a while, but there it is. So this can only happen every 3 minutes. Any more often, it could possibly cause screen damage. Obviously, it's slower than a normal screen, but this one does not require power after that update, and even the update uses very little power. The whole idea is to have this thing running for weeks at a time with very little battery needed. Here you can see the current stats it has. The date is wrong, yeah. Even watch, so if I unplug it, right, it's unplugged, but look, the screen is still working, and the screen will continue to be this forever because it's e-ink. It's like an etch and sketch. So it's kind of like a cool feature of it. Okay, so here we have the code for the project, and I'm going to work through this as I can. So we have ignore the cases stuff, but I'm in the middle of this, and I want to show it, you know, again, because it's kind of like an update. But I've been working on this for a while. Or I was working on it, and then I stopped for a long time because creating a case for it without a 3D printer would have costed me a massive amount of money. Just one print for someone else to do it, like a company, would cost me $80, and the whole iteration thing of printing, you know, would have made it quite hard to do more than one print. And I have a printer and I've been running it, and that's why I'm bringing this up now, or going back to this. But I have like 15 prints or 15 iterations, and that would have costed me a lot of money if I did each one, not to mention time, because each print takes about a 3-week period from you telling them you want it to actually getting it. So anyway, so here's the code, and this is all written in Python. It's MicroPython, so it's like a special version of Python meant to run on embedded devices. And obviously it's Python, so like it's really easy to work with, but you know, it's kind of like it's gonna use more memory, and so I had problems where I was running out of memory. The battery only lasts 8 hours even with some stuff, and I could probably make things optimized. But anyway, I'm gonna try to rewrite it in C and see if I can get it better. So I have a bunch of libraries and stuff on the Pi. I don't know how big the libraries are, how much that is taking up in space, but it all fits. And so I have a bunch of stuff. Let's just start at the beginning where it would go. So it's going to release the displays, and then it's going to set a bunch of variables to get all of the stuff, all the pinouts I have for the ESP32 to go to the display and some other stuff. So we get the display, we set the width, the height, the highlight color. The display is a tricolor e-ink, so it can do black, white, and red. We're using Adafruit libraries. We set the zeroed out sea level pressure. I don't know what it is. I just set it. The temperature offset, because you got to account for all the sensors and devices creating heat, so you just always offset for that. Again, don't have the case, not there yet. We set up the SD card reader. We have the chip select, the SD card, and we set up a list for samples. This is like every time I run it, I will get a sample of the current information. I'll show that later. We get the battery, we get the real-time clock. Walk through. So right here, I have the main embedded device. This is an ESP32 feather, and then it has a bunch of wires leading. So here I have an e-ink display with an SD card reader, so I have the micro SD, and then here's the display I have, and the font I stole from the Minecraft. And we have various things here. I'll walk through the code later and show what all of them are. But I'm basically storing stuff in I'm collecting data and then storing it in the SD card. Setup, we open a file on the SD card. It's the log file, and the log file is it's set to do time, temperature, humidity, pressure, gas, altitude, memory usage, battery voltage, and battery percent. I did everything that I have access to. It's logging all it can. A lot of it I probably don't need, but it's cool to have. And then it'll do this in a CSV format. As you can see, it's comma separated values, and then it ends with a new line. It's going to be writing these numbers. So we can see we do a sprite renderer, and this is a class I set up. So if we go to that, you can see here what I do is when I first init this, or when I first create this first instance, I get all of these sprites, which I can show later, and they're all the different images that showed up on the screen. And then I also have a character set of the characters I need. I set display, and then when I do that, enter that with thing, I just basically set the display IO group. When I exit, when I do an exit, so that with is kind of like a special Python thing. So then when I exit, it'll refresh the display and draw everything to it. And then I have some helper functions like write, get, load, square. And basically the first time I try to render an image, it'll load it if it doesn't exist, and then run it. It's very stateful, but it's meh. So then we're going to do display. So first we render a square. That's just to blank out the display and show a white background. I have some padding, and then I basically just do temperature, humidity, and these are special characters, so if it sees that T, it'll put the temperature icon. And I'm rendering I'm rendering just the symbols right now, and then we get the real-time clock, and this is rendering right. So do that. All right, underneath it, so I get the temperature, and these are values I get from up here. So I'm getting the temperature and the mem usage, and then I'm also getting relative humidity, pressure, gas. Right, I'm just drawing things to the screen in a nice format. This is every 3 minutes. So every 3 minutes, I'll render the display with what it currently has going on. And then after I render, then I'll store all the samples I've collected in the past 3 minutes into the SD card, doing it all at once, because doing that is more memory efficient and battery efficient than opening the file each time. And all I'm doing is I'm just converting the numbers into a string, characters, and then I'm writing a new line at the end. And then after that I clear the samples because I don't need to do it again. So then right here we have the device that measures the humidity, temperature, oxygen levels, all that kind of stuff. And then finally right here is in RTC the real-time clock. So this way, even if it powers off or loses power, then it'll stay on, or it won't lose the current time. And that helps for the logging. So then I don't have to reset the clock every time I turn it back on. The samples are getting like the time, the temp, all that stuff, and I'm just getting the raw values from the sensors and storing them as strings. So they're all going to be a float. Or there's like something where the sensors only go up to a certain precision level. They don't do arbitrary numbers if they don't know it. It's like not super memory efficient. There's something I'll probably fix in C. So each line or each sample in the log will be like, I think it's 6 characters or 6 bytes per value in here. So I don't know if I wrote it, but it's probably going to be like 48 bytes per, but I can really shrink that down a lot if I use a proper packing method. So this is going to be pretty big, in the log, but what I can do is make it quite a bit smaller by using some C struct magic and getting the size down to as small as I can get it, and then it'll be much more space efficient and memory efficient because it's using less memory for logging these things. And yeah, that'll be pretty nice. But it's like, I can show it later, but each thing will be like so many bytes because I'm writing them just as characters, but I could store them as the actual number values, which would use a lot less space. And I can also probably do some other magic too. We can talk about that later. Then I sleep for a second, so I'm basically logging once every second. And this is basically asking the display if it's ready to update, but so because like what if it's a different display and it has a different update time, so it's just better to ask the display like, hey, are you ready yet? Are you ready to draw something new? And that's all that code. So also this battery, the clip popped off, and now I'm gonna have to either resolder or hot glue it back into place so the battery works again. My next update will probably be either when the case is finished or when I rewrite all this code in C to be much more efficient. And I'll kind of walk through what I did and how much better it is, or hopefully better at least. And I'll walk through what kind of methods I did in my process to make it more efficient. So that'll be all from me in this part.